Hello student, this is Satya and in class 10th physics today we are going to study about the very important property of the conductors and also in case of insulators and semiconductors. As you observe that in various phenomena that when you connecting the circuits and switch on the power supply, then you find that some bias get flow of current easily, very easy, but sometimes some other bias are get heated very easily. They cannot flow current easily from one point to another point. Then what happens behind the heating effect of the bias? Why the devices get heat up immediately, and some of them are heating by taking some extra time. So what can you observe that there are in circuits, like there are thin bias, thick bias, and long bias, and a small piece of a wire. So what parameters determine the use of these bias? So actually the reason behind that is resistivity of the materials, and this is the intrinsic property of the materials. On the basis of this, any material should be good conductor, insulator, or semiconductor. This can on the basis of this parameter we have to determine it. So let us study about the resistivity. What do you mean by resistivity, and how will you define it, and how it affect the flow of charge from one point to another point? And also it is known as specific resistance. Okay, resistance, it is the term comes in the uh, explanation of electric current or flow of charge from one into other end. Let us see about the resistivity. Okay, by the experiment it is found that resistance of a given conductor is directly proportional to its length. Basically resistance means the hazards comes in the fluency of the flow of electric current. Okay, so by experiment it is found that the resistance of a given conductor is directly proportional to the length of the conductor. Suppose that any conductor, like this is a conductor and its length is small l, and suppose that its resistance is capital R. Also suppose that its area of cross section is capital A, and the material by which it is composed, it is known as the uh, it is known as by the term rho. This is the rho. Okay, so let us see first point. Resistance of a conductor is directly proportional to the its length. Secondly, we have observed that resistance of a given conductor is inversely proportional to the area of cross section of the conductor. It means जो रेजिस्टेंस होगा इस कंडक्टर का वो पर्टिकुलरली इस एरिया ऑफ क्रॉस सेक्शन के इनवर्सली प्रोपोर्शनल होगा. इट मीन्स क्या हुआ, व्हेन वी इंक्रीज दिस एरिया ऑफ क्रॉस सेक्शन then resistance will be lower, and if we decrease the area of cross section like that, then this will be the resistance will be the higher. It means there is a lot of hazards in the flow of charge. Okay, now combining equation 1 and 2 we get, on combining equation 1 and 2 we get R is directly proportional to L upon A, where on removing proportionality constant we include rho, and this rho is called a constant, and this is also known as resistivity of the material. It is sometimes also known as specific resistance. So we can say that we can say that resistance equal to rho A upon L. Resistance equal to rho L upon A. We have seen that R proportional to L, are proportional inversely proportional to 1 upon A. On combining these equations, we get R is equal to rho L upon A, where rho is the resistivity. It is known as the specific resistance. So from this formula we can define specific resistance as rho equal to Ra upon L. This is the quantity which determines the specific resistance of a given conductor on the basis of their resistance, area of cross section, and length of the conductor. So if we put equal to 1 meter square, suppose that any conductor of cross section, suppose that this is the length and breadth, all are 1 meter cube. This is also 1 meter. Then we find area equal to 1 meter square. So if the area of cross section is 1 meter square and length is also, suppose that its length is 1 meter, so in this case we get rho equal to R. It means resistivity of a conductor is equal to the resistance of that conductor. It means we can define resistivity as a specific resistance, the resistance offered by the conductor per unit length having unit area of cross section. So you note down the definition. The specific resistance can be defined as the resistance offered by a conductor is per unit length having unit cross sectional area. So let us see the unit of SI unit of the resistance. As we know that unit of resistance is ohm, and area unit meter square, and length unit is meter. So in this case we get the SI unit ohm meter. So this is the SI unit of the specific resistance. Okay. Now some important points, let us see about it. The resistivity does not depend its length or thickness. It depends on the nature of the substance and temperature. It means if we change the temperature of the conductor or environment, then there will be also change in its resistivity. Okay. Let us see the example of some materials at 0 degree centigrade. So first of all we take conductor. In conductor, silver, copper, aluminium, tungsten, iron. So let us see the values of these are the values of the resistivity, and here the best conductor of electricity is silver because it has low resistivity, 1.6 into 10 to the power minus 8 ohm meter. So this is the best conductor of the electricity. And after that, copper and aluminium are also used to make electrical bias. Okay, these are the best suitable for making electrical bias. Now again see, there are some important alloys are the mix of metals and non-metals. So first alloy is manganese, tungsten, nichrome. This is most important you keep in your mind, and this is question asked in your exam, that what is the composition of manganese, what is the composition of tungsten, what is the composition of nichrome, and where it is used. So let us see, the manganese is made up of copper, manganese, and nickel, and its resistivity is 44 into 10 to the power minus 8 ohm meter. Constantan is made up of copper and nickel, and its resistivity value is 49 into 10 to the power minus 8 ohm meter. And also nichrome is made up of nickel, chromium, and manganese and iron. So this is the nichrome having resistivity value 110 into 10 to the power minus 8 ohm meter. So now these are most important section of this lecture. So you note down and keep in your mind, save for future and your exam. Now again see the semiconductors. There are another question coming from this section, and which material has the resistivity 0.6 ohm meter. So you can easily tell them answer is germanium, and another material is silicon, which has 2300 ohm meter resistivity. Now let us see the case of insulators. In insulators diamond, insulator like plastic, paper, etc. lot of things comes under this section. And let us see the example of diamond. Here the value of diamond vary 10 to the power 12 to 10 to the power 13 meter. And also ebonite, sorry, this is ebonite, ammonite नहीं है, ये ebonite है. तो ebonite 10 to the power 15 to 10 to the power 17 meter ohm meter. Okay, so on the basis of these observation, we can conclude that resistivity of insulators greater than resistivity of semiconductor, and these both greater than resistivity of alloy, and resistivity of all the three greater than resistivity of conductor. So here we can say that if any material have least resistivity value, then it is the best conductor of electricity, and other hand, if any conductor have very large resistivity value, then it is the bad conductor of the electricity. It will be the bad conductor. So sometimes question comes, what are type of conductors used in the electrical heating appliances like electric iron and toaster? So here as we know that resistivity of alloy is greater than pure metal. So in this case we use the alloy, because alloy does not get oxidized. It means they doesn't burn in the presence of oxygen, and they also work safely at a very large temperature. So here we use nichrome alloy. Nichrome alloy has very low resistivity and does not undergo oxidation even at a high temperature. So this is the lecture totally. I hope you understand, and finally you have to note down and practice about this section. In next lecture we will study about the questions related to resistivity, resistance, and length and area of cross section. So tell you thank you very much, and note down this topic in your notebook. और अगर आपको लेक्चर अच्छा लगता है तो चीज़ों को लाइक करें, सब्सक्राइब करें और शेयर करें. तो इससे और साथ में कमेंट करके भी बताएं कि आपको ये चीज़ें आपको अच्छी लगी हैं, जिससे कि हमारे चैनल जो बना है उस पर हम और सारे लेक्चर को अपलोड करें, और जिससे कि आपका नॉलेज अच्छा हो सके. Okay, thank you very much again.